Okay, for the first problem, we're asked to find the maximum area of the right triangle with hypotenuse 44. So maybe you might know the area of a triangle. Let's just go ahead and draw it out so you see what that looks like. So a right triangle with hypotenuse of 44, and we can call this x and y, and we want to maximize the area. The area of this triangle is 1/2 base times height, or x times y. Now we could just take the derivative of this, but we said that if possible, for us to not use two derivatives here, two different variables, but to switch it to one. So how can I make x become y or y become x? And that's right here. X squared plus y squared is equal to 44 squared. And then I want to solve for the variable. Let's solve for y. Y is equal to the square root of 44 squared minus x squared, right? Because we're just minusing the x squared and then taking the square root. It's going to be the positive version because we can't have a negative y. Now we're just going to rewrite that a is equal to 1/2 x times the square root of 44 squared minus x squared. Okay, now to maximize this, we take the derivative and set this equal to 0, looking for critical points. We'll call this a prime is equal to, we're going to use the product rule here, so derivative of the front is 1, leave the back alone, through parentheses, plus the derivative of the back, which is 1/2 square root of 44 squared minus x squared, and then we're going to multiply this by negative 2x and leave the front alone. We're going to set that equal to 0. We're going to rewrite it as 1/2 in the front, and we have to write a common denominator, right? So we're going to multiply both sides by the square root of 44 squared minus x squared, so the top is no longer the square root. The right side is a minus x squared all over the common 44 squared minus x squared. And the goal is to make this equal to 0. The top becomes 44 squared minus 2x squared, and we're going to make that go to 0. This happens when move it over, divide by 2. It's going to be, and then take the square root of that. So let's see, we write it as x squared is equal to 44 squared divided by 2. This is 22 times 22 times 2 times 2 over 2. Okay. So we look at this as x squared is equal to 22 times 22 times 2. We take the square root of both sides. X is equal to 2 square root, so 22 square root of 2. So that's our x value. If that's our x value, what's our y value? If we plug this into here, what's the correct answer? Find the maximum area. To find the area, we need to find x and y. So if we know x is 22 square root of 2, let's find y. Y is equal to square root of 44 squared, so minus 22 square root of 2 squared. You can say this is, I'm kind of lazy, I don't want to do it. I'm going to say 22 squared times 4, because it's 2 times 2. Yep, and then over here we see it's 22 squared times 2 also. So we can actually take this factor out, a 22 and a 2 from the problem, and we're left with 2 minus 1. Okay, and 2 minus 1 is just 1. Right. 2 minus 1. Yeah, 2 minus 1, so that's just 1. So we're left with the square root of 22 times 2, which is just 22 square root of 2. And that's our y value. Turns out our x and y value are exactly the same. So a is equal to 22 square root of 2 times 22 square root of 2, 1/2 in the front. So that's going to be 1 over 2, 22 squared times 2. The 2's divide out. Answer is 22 squared. 22 squared is 484, probably. So really, the only calculus move here is actually this step here. We know we have to solve for the derivative of a and set that equal to 0. We don't want to do two variables, we change it to one variable. And then we know the fraction is going to go 0 when the 0 is on top. So right here. The water is flowing at a rate of 30 meters cubed per minute, so that's our volume rate. The volume is equal to 30 meters cubed per minute. And that's our rate, so this is dV over dt. And then we have a shallow conical reservoir, right? And the funnel down, and the base of the radius, this is the base of the radius, is 35 meters. The height is 4 meters. How fast is the water level falling when the water is 2 meters deep? Okay, so we also have water in here, and it's going down. So we have a radius and a height inside this. So it's like a smaller cone inside the cone. And we can write a ratio right now. R over H is equal to 35 over 4. That's something that we'll use in a little bit. And you can write this a lot of different ways. You can write H over 35 is equal to R over, H over 4, 4 and R over 35. But that's actually the same ratio here, just spun around a little bit. H goes down, 35 goes up. Okay, so no matter how you write the fraction, it's going to be okay, as long as we pair them up correctly. So we'll figure out which one we want to use later. How fast in centimeters per minute is the water falling? So we're looking for dH over dt. That's what we're looking for. At at H is equal to 2. So we have to come up with a volume equation. So our volume equation for a cone is 1 over 3 pi r squared h. That's our volume equation. And we know we're going to take the derivative of this. We know we need to take the derivative of h. That's what we're looking for. So the variable I don't want is kind of like the r. So I want to change r to an h. So let's look here. I think I can change this one pretty easier. H is equal to 4r over 35. And I'll take it. So 1 over 3 pi 4r over 35 squared times h. Whoops. I messed up, sorry. I want to change my r to h's, not h's to r. So my r is equal to, using this one over here, 35h over 4. So 1 over 3 pi 35h over 4. We're going to square that, and we end up with some crazy number, like 35 squared over 12 h. Oh, it's not even 12, it's 4 times 4 is 16. And then 16 times 3 is 48. And then h cubed, and don't forget the pi. And h squared times h is h cubed, and then 35 squared and 4 squared. That's our v value. Now the derivative of this is going to be pretty easy, because remember that's just a constant here. Is h changing? Yeah, it's falling. Is the v changing? Yep, that's falling also. So these are variables for us. So dv over dt is equal to 35 over 48 pi. And then the derivative of h cubed is 3h squared dh over dt. And as you can see, we have dv dt, we have h, and we just need to solve for dh dt. I'm going to start plugging in. We know this is 30. We're going to get rid of the 48 over 35. We're going to get rid of the pi that's on the bottom. And then we're going to get rid of that 3. And then we're going to get rid of the h squared. H squared is what? H squared is going to be, h we said was 2. So 2 squared is going to be 4. So see all these things that we're multiplying over here? That's all on the bottom. And it's h squared, I'm sorry. Oh, we raised squared it. Is equal to dh over dt. Again, what I did was we have, right? So we have to get rid of all of these. And it turns out all this stuff goes on the, all this stuff here goes on the bottom, and this one gets flipped. Okay, if we want to simplify, we see it's 4 times 3 is 12. 12 does cancel out with 48 to become 4. I see 30 and 37, it's 6 and 7. And that's, alright, then we can't simplify anymore. And that's our dh over dt. So 24 over 7 pi.